Good morning, everybody. My name is Kathleen, and I'm an application engineer with TriStar, and we're going to talk about Mathcad, and I'm presenting this from Chicago. So nice to have everyone on the call with us. What I want to do is I want to review some of the time-limited offers that we have available through TriStar. It was on the TriStar's website that I had displayed on the left-hand side. But for those of you who didn't see it, if you are using PTC Creo Parametric at all, there's a time-limited offer on 40% off any module, 35% off any Creo Essentials or package upgrades. And if you are not familiar with Creo Parametric and you want to go ahead and try it out for 30 days, feel free, you can. And that's one of the things I'll be showing you guys is the integration of Mathcad Prime with Creo, and Creo 4.0 is the latest and greatest out there at the moment. So you can access all of these time-limited offers from PTC's website and from TriStar's website, tristar.com. Okay, so if you go to tristar.com, just the homepage right here has some of those TLOs, time-limited offers that you guys can take a look at. But our purpose for today is to discuss Mathcad. So we'll go through a brief overview. When I go through the demonstration, I'll do a basic demo, what everybody would be using Mathcad at a minimum for, but everybody's math will be unique to your systems that you guys are creating. So we'll talk about the interface if you're new to Creo Prime, the natural math notation, units awareness, the documentation piece with Mathcad, which I think is one of its strengths. We'll talk about the integration with third-party tools such as Excel. That's always a hot topic, so we have to discuss this. And then I'm going to take it a step further and show an integration presentation with Creo Parametric, utilizing the engineering notebook. All right, so what is Mathcad? Mathcad is going to allow you to capture your engineering designs in a readable form that other users can read. It's not cryptic. You don't have to go in and audit an Excel sheet, which could be difficult. You're not using a piece of paper that some engineer doodled their engineering calculations on. We're able to capture this intellectual property and tie it in to our designs if we need to. So it's intuitive. You should be able to open up the program and just start using it. Of course, I would always suggest you guys take the 2-day Mathcad Essentials course, which ramps you up very quickly. The first day talks about the basics, creating variables, defining your math and your functions. The second day is a little bit more advanced, where we do some optimization, differential equations, a little bit of programming, but it's just a 2-day class and it's really easy to use. But within Mathcad, there's also some tutorials that you can open up and run yourself. Taking the class is not a showstopper as far as utilizing Mathcad. I think it's that easy to use, and it's in a readable format. Okay, you're going to see the math the way you learned it in school. You see your square root symbols. You see your integrals if you took calculus. So I think that's very, very powerful with Mathcad. So Mathcad's readable. And some of our competitors, it's not always readable. You might have to know some proprietary scripting language. And Excel, here's an example of an Excel function that might be a little difficult to go in and audit. You have to go in and dig into all of these cells, right? D5 might be equal to the summation of A1 through A20 times B4, all divided by D1. So you have some functions that are kind of hard to audit, and I think that's really where PTC Mathcad shines. And believe it or not, Excel is our biggest competitor, which surprised me when I heard that, but it's because everybody has Excel. I don't want you, though, to use Mathcad to replace Excel. Excel is a very powerful tool. I love it. What I want you to do, though, is think about using the right tool for the right job. And Excel does a really great job of capturing information, but then we'll be able to import that data into Mathcad to utilize it for our engineering calculations. And I'll discuss that a little bit later within Mathcad. Okay, so the current capabilities, what you see is what you get. You're almost typing it out in the document that you see, a printable form. Okay, so you've got text and images, you have math, you have control of your math formatting, you can bring in different types of plots. We have 2D XY plots, you can do contour plots, many different things that you have the ability to bring in. There's some advanced engineering math tools. You don't need to know programming in order to utilize Mathcad, but you can bring in programs. I like to think of a program as a multi-line function. That's what I call a program. And we've got training classes that talk about how to utilize all of this, and they break them down so you are completely familiar with how to use some of these tools. We have solve blocks, and I'll show you an example of a solve block in a future worksheet where you have the ability to solve some more advanced equations, like maybe nonlinear systems of equations or differential equations. Optimization is all utilized using solve blocks, okay? We can bring in custom functions if we need to. You can do linear algebra, aka matrix math, inside of Mathcad. We have the ability to integrate with third-party like Excel, which I'll show. It is supported with Windchill, if you guys have Windchill, which is PTC's data management tool. And I'm going to be showing you guys the Creo Engineering Notebook in a few minutes when integrating with Creo. So here is a quick slide that shows the interface. It's a little busy, but I decided to include it just to give you guys the first snapshot of what Mathcad looks like, but I'll definitely go through the demonstration and show you guys the interface live. What's new in Creo 4, and there's a PDF, it's only about 12 pages, but they've made some nice enhancements. For example, areas, we can lock areas now. You can save this file as a rich text format so it could be opened up in Word directly if needed. It now supports Windows 10. Some of you guys on the line, that's been one of the critical showstoppers with Mathcad Prime is you guys have upgraded to Windows 10, but Mathcad wasn't supported yet. So Prime is now supported on Windows 10. There's now a Works formula for stress and strain, I think version 6, that is available, I think, for purchase. I don't think it comes right out of the box, so I'm just making you guys aware of that. And some critical bug fixes that they fixed along the way. There's some document performance improvements that are listed over here on the right-hand side, and I can definitely share this presentation with you guys after this call. Plot performance improvements, you can plot 2 million points per trace versus 500,000 previously, so you can get some pretty accurate, smooth plotting results. Areas is something that we were able to utilize, especially in Mathcad 15. You're able to create an area and lock it. I believe Mathcad Prime 2.0 reintroduced areas. See, PTC acquired Mathcad, I think at version 13, probably around 2006, and they rewrote it to create Mathcad Prime, And all of the functionality that's in Mathcad 15, most of it has made it into Mathcad Prime. Not 100% yet, which is why Mathcad 15 is still supported. But now they've, I believe Prime 2.0 brought in areas, but you weren't able to lock them or protect the information that was inside the area. And Mathcad Prime 4.0 has reintroduced that. So you can make it password protected in order to change the information that's within an area. And that's a popular feature. And that may have been why some people were hesitant to move to Prime, is for this area protection, and now it's supported. So if that was your showstopper for upgrading 4.0, Prime 4.0 is your release. They're really working on the integration, not only with Excel, but with Word. If you want to bring in different images into your Mathcad worksheet, you have the ability to do that. You can copy and paste from these third-party applications as well. But I think one of the popular reintroduced features is this rich text format. Again, available in Mathcad 15, was not available now until Mathcad Prime 4.0. But what you can do is you can save this off as a RTF file, which is rich text format, and you would be able to open it up directly in Word. If you wanted to share your math worksheets, but not everybody has a license of Mathcad, they would be able to open up that worksheet in Word. Now, what it would do is it would just take some of those symbols that upgrade automatically inside of Mathcad, and it saves them off as images or pictures inside of this RTF file. So it's not going to update as you're making changes to the Mathcad worksheet. You would need to go in and re-export it if you made any changes, so that way they can see the latest and greatest information. One of the things that you can do now in Mathcad Prime 4 is you have the ability to break an equation. For example, if you have this equation that's really long and gets off of the printable page, but you want to show the entire equation, you have the ability to break it. So it's now shown in multiple lines if needed, all in the printable region. So I think that's going to be pretty powerful. So for some of you guys who have some sophisticated math in your systems. But let's go right into Creo and show some of this functionality. And I meant to say Mathcad. I work in Creo and Mathcad at the same time, so I apologize. So we are in Mathcad Prime 4.0. And let's first talk about the interface. Okay, so here we have a ribbon interface. I believe some of you guys on the call might still be in Mathcad 14 or 15. Those still had toolbars. They've gotten rid of the toolbars from Mathcad 15. In Prime, we now have this ribbon interface with pull-down menus. So on the Math tab, you can bring in your math or text. We have different operators, right, in the natural math notation. So if you wanted to do an integral or a derivative, okay, you've got your linear algebra operators down at the bottom. We've got symbols. So we've got Greek symbols and lowercase and uppercase if you wanted to utilize any of these for your variable definitions. We have programming pull-down menu in here, which you would have to utilize if you bring in a program. We have different constants in here. For example, C is the speed of light. Okay. And one of the things I'll show you is if you're using one of the default constants, I don't know if this is coming over the recording, but your constants are green. The units are in blue. All right, so that's something to look at. I'll mention that again a little later. We have some symbolics in here that allow you to format the look and feel of the math that you're bringing in. So how many do you want to expand? Remember the FOIL method that we learned in school? You have the ability to expand or combine, float. How many significant digits do you want? Okay, we have units that we have the ability to manipulate. We'll talk about that a little later. The Input-Output tab allows us to convert old worksheets from Mathcad 15 into Mathcad Prime. That's this little converter utility. In order to utilize this converter utility, you have to have Mathcad 15, MO10, that's the date code, installed as well. And in order to utilize it from within Mathcad Prime, you have to have 2 licenses. You need to have one for Mathcad Prime and one for Mathcad 15. I'll talk at the end of this presentation on the workaround for that. There is a workaround if you only have 1 license available. We have the ability to bring in Excel. And we have the ability to assign inputs and outputs, and this is what we would utilize when we're integrating with Creo Parametric. We have a Functions tab. The Functions tab has all of these different categories of functions that you can utilize if you need to. If you click on All Functions, it'll pull up all of the functions on the left-hand side, and you can view them this way. You can also search for the specific function that you're looking for. Matrices and tables allows you to insert and create a matrix from scratch, or you can insert a table. I have another document over here that's already complete, but I thought this was a nice way of showing a table. You have the ability to define some of your variables utilizing a table. You can still use the colon equals for those of you who are familiar with Mathcad. I can still say A colon equals 10, and so A is defined as 10. Okay, you can still use your scalar math this way, but you can also define all of your variables in a nice clean table that you see on the screen, right? We have different plots that we have the ability to utilize and create. Many different types, XY plots, polar plots, contour, 3D. Okay, and you can add multiple traces on a single plot. I think, don't quote me on this, but I think you can have up to 16 traces on a single plot. We have the ability to format our look and feel of our math, which you might want to have different from the text. So the reader of the document can definitely see this is math versus text. I know it sounds so simple, but sometimes being able to emphasize the difference between the two is the look and feel of the math versus text is quite nice. There's a calculation tab here where we have the ability to, well, okay, right now it's set to auto calculation, so anytime I make a change in our worksheet, it'll automatically regenerate the worksheet. It'll automatically propagate those changes throughout the entire worksheet. Well, there could be a possibility where I've got something pretty complicated. And every time I change one variable, it takes a minute because my calculations are so complex. Maybe it takes a minute to propagate it through my entire worksheet. And if I'm making one change, I'm fine waiting. But if I'm making 5 variable changes at the top, I don't want to have to wait a minute for each change. That would take me 5 minutes to make changes to my document. So what I can do is I could stop all of the calculations, make my 5 changes, and then either manually calculate or turn auto calculate back on. So for performance reasons, you have the ability to manipulate whether it's calculating automatically or not. And then you have the ability to manipulate your origin variable. That's for any kind of matrices or arrays. What is that first upper corner? Is it the 0, 0 spot or is it the 1, 1 spot? You have the ability to specify the origin, what your tolerance value is, etc. The documentation tab allows us to be in page view, which is what I'm looking at. Page view it's like your print preview. What you see is what you get. This is what I would be printing if I were to send this to if I were to PDF it or send it to the printer. You could go into draft view. draft view is very similar to what we would have seen maybe in Mathcad 15 or before. And then this dotted line down here near the middle of the screen, that's your print margin. I prefer draft view. I meant to say page view because it's pretty nice. But draft view is nice because it would print, but maybe you want to have some engineering notes that are not in the printable range. You can have that on the right-hand side. I tend to do page view though myself. You can manipulate the grid, whether or not you want to show a grid or not. And if you do show a grid, do you want the standard grid or a fine grid? This standard or fine is probably something I would manipulate near the beginning, because you can see when I change it from standard to fine, it kind of shrinks everything together. And if that's what you want, that's great. But if you already had a worksheet created, you might need to do some additional formatting. So that's probably a decision I would make from start. You can create headers and footers if you want to. You know, if I wanted to bring in a page number, I could definitely do that, and maybe I want it on this hand, and I can bring in my company logo. We can bring in a footer if we want to. So you turn on header mode and you turn off header mode. And if you do create a what you can do is you can create this header with your company letterhead, change all of your settings, change your units, change your grid size if you need to, manipulate the math formatting and the text formatting. And what you can do now is you can save this out as a template. And you can always start with this file when creating new worksheets, so they all have the same look and feel inside of Mathcad. And then we have a resources tab over here. The resources tab allows us to come in here and look at different references, alt reference documentation. Tutorials is where you would have a getting started guide. That would be very useful. You have the help tool. Any keyboard shortcuts might be useful. And let me tell you, there's a big Mathcad community out there. And if you need help, there's a lot of people out here that can help you and want to help you. There's some worksheets out there that they publish that you can utilize. You might want to audit them first before you just go ahead and use it, but there's a lot of stuff out there that you can definitely utilize, and I think it's pretty powerful. Okay, let's come in here and start talking about our natural math notation. If I want to add 36 plus 45, I can divide that all by 10. And you can see we have an obvious numerator, an obvious denominator, no confusion on we're adding first and then dividing. Okay. If I wanted to do an integral, we could. And I'm just going to hover over the integral sign, and you can see the little tag that comes up. It says integral. Control-Shift-I. Control-Shift-I is the keyboard shortcut for bringing in an integral. So I can either click it from here, or I can type this Control-Shift-I to bring in an integral. And so over here, with my 36 plus 45 divided by 10 example, we did a numeric evaluation, but you can also evaluate symbolically. So if I look at the sine of x dx and use an arrow, we have the ability to solve symbolically. See, if I said equals right now, it wouldn't find a result for our indefinite integral. But there's the exact result by evaluating it symbolically. Let me zoom in so you guys can see that a little better. And you know what, later on I'll probably show you guys a plot. So let me come in here and define this as f of x. So we'll define f of x to be the sine of x dx. All right, so what I did is I created a definition statement. A definition statement is where you're saying that I want to define A to be 10. I want to define B to be 30. Now what we can do is we can define C to be the square root of A squared plus B squared. And I'm just using the keyboard to type this in, and you can see the natural math notation. Now someone might have noticed, wait a second, C is a default constant. It's the speed of light. Well, Mathcad reads from left to right, top down. So if I were to evaluate C right here, C equals, it's going to give me the speed of light. But I've redefined C to be the square root of A squared plus B squared. So from here on down, or to the right of this, or down, if I say C equals, it's going to give me the result of the square root symbol. So the difference being, and I hope this shows, the default constants are green, but if I've redefined it, it's just the default text formatting. It's not green, it's black in this case. You may also want to show your work. This is where those keywords are very helpful, so I can explicitly show what the values of A and B are. Okay, so it can verify what values we're using. And if I meant, oops, I typed in 30, it meant to be 3.0, it'll automatically propagate our results to wherever we're using them in our document. If this was in Excel, right, we would be raising this to a power of 1/2. Well, now I'm assuming that whoever's reading this Excel sheet, if they dig into their cells to audit it, that they know what the power of 1/2 is. Do they know that that's a square root symbol? Maybe, maybe not. Here is a square root symbol that we learned in 6th grade. Okay, let's talk about units. Units is pretty powerful when it comes to engineering documents, isn't it? Wasn't there a Mars rover that slammed into the planet in the 90s because of units? You know, millions of dollars out the window. So what I'm going to do is I'm going to come in here and let's add 5 feet plus 6 inches plus 2 meters plus 10 furlong equals. Mathcad recognizes all of these as units of length, and it's going to give us our results in units of length. Okay, let me come in here. I'm just going to copy and paste this a couple times just to show you. I may have copied it a little bit more than needed, but that's okay. If I were to, maybe I was doing some data entry. We're modernizing all of our documents, and we're taking all of the documents that are handwritten or scanned in a PDF, and we're going to translate it into Mathcad, kind of modernize our data that we have so we can utilize it. And I'm doing some data entry, and instead of M, I accidentally type S. Mathcad recognizes that these units are not compatible. S is for seconds inside of Mathcad. So what it won't do is it won't erroneously calculate a result that could possibly be propagating into other formulas downstream in the document. Okay, so let's come in here and change that back to meters. If I wanted my results to be in centimeters, I can just backspace the unit, type in centimeters, and you'll see it'll automatically calculate the result in centimeters. So our powers have gone up by 2. Or feet, if I wanted this to be in feet instead. Let's do inches. Inches. There, now it's converted to inches. If I wanted to change the units of the entire worksheet, that's when you would come to the Math tab up at the top. And there's different unit systems. We have the SI unit system, the US customary system, and then centimeter, gram, second. So if I said US customary, I'll select it, and it automatically propagated everything. You can see the feet, except for this one, because I specifically said I wanted it in inches. So any of the ones that you specifically type in. that are different will remain the same. And so if I want to go back to default, usually I just recalculate it. I just hit equals again, and it'll go back to whatever the default units are for the worksheet. All right, you can come in here. There's many different units that you have the ability to utilize. For those of you who utilize force, we have kip. Okay, units of length. They're all in here. Smoot. For those of you guys who know the gentleman who went to MIT, got a Wikipedia link, Smoot. There's a funny story when it comes to that. Okay, little homework for you guys. Let's talk about plotting. So if I go to the plot tab, I'm going to go ahead and plot this f of x formula. In fact, I'm going to go ahead and drag it down a little. As you can see, you can move your math wherever you want, almost like a whiteboard interface. And it does snap to these little grid lines if you need to. Okay, and we're going to create a plot. We're going to bring in a 2D plot. And because I went off my margins, it automatically toggled me into draft mode. That is new in Prime 4.0. And what I'm going to do is I'm going to go ahead and put in x in the domain area. And for the range, we're going to plot f of x. Click away, and there it is. And if I were to select this plot, a lot of the functions become available for manipulating this. So what is the trace color that I wanted? Okay, what's the thickness that I want? And if I had multiple traces in here, so you can add a trace if you need to, you can emphasize one or the other. You can bring in markers if you need to. Where is, pi over 2, and negative pi over 2, and you have the ability to move markers along the plot. Let's bring in a vertical marker. And I want this to be at pi over 2. So pi would be P control G for the Greek equivalent divided by 2. And it'll move that marker to where that is. Okay, pretty easy stuff to do. Documentation. Well, up until what I've been doing so far is I've been adding labels showing what I'm discussing at this particular point in time. That's the most basic documentation, but I'm documenting my worksheet here. That's why I really opened up this CAM Design Finish. I really wanted to show you the documentation piece of this. So this is something that PTC created. We got some headers, we've got some plots, and it's showing us what is the purpose of this particular document. Here's our variables and what our variables represent. It's almost like writing a program. If anybody reads programs, especially a program that somebody else created, you appreciate the comments that come along with it. That's exactly what this math is doing. Here we've got some plots, and you can definitely move these markers if you need to. Right? You can see the natural math notation. And we have some pretty sophisticated stuff in here. We got programs, multiple traces on a single plot. If you needed to emphasize one over the other, we could. And so that's really why I wanted to bring this document in, so you guys can see a more advanced example of a worksheet that's documented out. I think I can come in here. Let's see if they got one that's long enough where I can show. That equation break. Let's try this one right here. Okay, so if I go to math and I go to operators, here's the equation break. And so I know that this is going to be a minus, right? So I can break it with a minus, although I probably broke it. That's a minus minus, right? And that might be a positive. So if I do an undo, move the cursor here, and say minus that way. No, that still didn't work. Okay, I'm going to select it right there. There we go. So select the actual minus sign. You'll see it'll be selected, you can tell, and then you'll use that little operator to break the equation. Just wanted to show you that. That's something that's new in 4.0. You don't have the ability to do that in previous versions. Oh, and let's show the area. Let's see if I can do the area here. Well, you know what? I'll go to my document. Okay, so if I wanted to show, I'm gonna take these units, try to select all of them. Okay, and I'll do a Control X to cut. Let's come in here. Let's create an area. So that would be under Document, Area. Let's paste. So I brought my units inside of the area. And what I can do is I can collapse the area. You might have, you know, your math is your proprietary information, and you want to bring it into your Mathcad worksheet. You have the ability to collapse it if you don't want it shown in the printed document. But what you can also do is you can protect it. If you right-click this symbol right over here, if you do a right-click, you have the ability to protect. And this is where you can bring in a password. And you'd have to know the password in order to unlock it if needed. So if I say, I enter in now I can't even come in here and type anything. I can't make any changes to it. And that's going to be very powerful for a lot of you guys. Okay, so that's going to be new in 4.0. Let's talk Excel briefly. There's many ways to integrate with Excel. Some are better than others. There's some pros and cons to all of these methods. Method number one would be to do a straight copy and paste. If we open up Excel and we select our data set, do a Control C to copy, and come into Mathcad, Control V to paste, we might need to come in here and name our columns so that way we can utilize these columns in our math. So I could say A equals, right? A equals, and it gives me just column A. The benefit to this is it's easy. The downside to this is there's no associativity to this and the Excel worksheet, which is if you did not want any associativity, then a copy and paste works great for you. It's simple, it's easy, it's pretty intuitive, you should all know how to do it. The second way to bring in Excel data would be to use this read Excel. So I'm going to create a variable called data, :equals, because I'm defining this to be, and I'll browse to my worksheet. By default, it will bring in all of your rows and columns, but you can specify a subset of data if you needed to. What rows and columns do you want to bring in? I'll go ahead and hit insert, but when I say data equals, there it is. Okay, so this whole table is called data, and we can apply units if we need to, but now is when we can do our matrix math. So if you wanted to do the cross product or column extraction, row extraction, matrix transpose, you can vectorize your matrices if you need to. All of this we talk about in the 2-day class, the essentials class. We talk about all of these different operators. Now the benefit to this read Excel is you now have some associativity to it. If I were to go, not everyone's going to have a license of Mathcad. Maybe the person who's capturing the data is using Excel. The person who's analyzing the data might be using Mathcad. Well, if that data changes at all, from the Excel side, you can manipulate those values and propagate it. And next time we open up this Mathcad worksheet, we would have all of those changes because we're reading it in from this specific location. The downside is we now need to maintain 2 files. We need to maintain this Mathcad file, and we need to maintain the Excel file. The third way of integrating Excel would be to bring in an Excel component. And what you're doing with an Excel component is you're bringing Excel right into this worksheet. So if I were to select the cells in here, you can see it's launching Excel, and you can utilize the power of Excel to capture your data. Okay, and when you hit close, you'll see that that data is inside of Mathcad. The benefit is I only have one file that's incorporating Excel and Mathcad. The downside is now it's going to be a heavier sized file. So if you needed to, depending on the complexity of the files and the data that you're bringing in, it might not be a size that you can now email as an attachment. You might need to send it off another way, either FTP side or removable disk or Windchill, right? So pros and cons to each method, very useful. All right, so now what I want to do is I want to talk about the integration with Creo. And this is going to be really powerful because if you have some engineering math that's driving the design of your Creo file, you have the ability to integrate that. You don't have to be dependent on the scratch pad. Someone created the design based off of the engineering that they have in their Spiral notebook. And then, 5 years from now, where is that math? We have the ability to tie it together. So we have the ability to document the design intent, bring in analysis-driven design, and it's also a way of verification and validating the design based on the engineering math. And with, I want to say it was starting with Mathcad Prime 3.0, and I think Creo Parametric 3.0, they've introduced this notebook feature where you have the ability to toggle between Mathcad and Creo seamlessly. And that's exactly what I want to show you guys. So what we need to do inside of Mathcad is designate the inputs. What are the inputs that we're bringing into Mathcad from Creo? Okay, we can use relations to tie it all together, relations and parameters. What are the outputs? So the outputs are the outputs that we're pushing from Mathcad out to Creo, and it can drive our analysis. Okay, so what I need to do is I need to close Mathcad because, cancel. This spring worksheet is what we're going to utilize. So it's a preloaded worksheet. We've got some spring stuff. We're going to work on a spring. What's going to be the applied load. And here's a solve block because our goal is to minimize the weight of this particular spring. And so what's a solve block? A solve block is a special math construct that can solve systems of equations. So you have a couple guess values. The guess values are more for the algorithm in Mathcad. Where can we start? And then you have some constraints. We've got the spring function, deflection constraint, shear stress constraint, but also some design constraints. So the diameter of the wire has to be between 1 millimeter and 5 millimeters. The coils have to be less than 10. The diameter of the coil has to be between 6 millimeters and 20 millimeters. And then here is how they're closing out the solve block with this minimize function. Okay, if I were to come in here and cut this minimize function, you can see it's not calculating our optimal spring dimensions for the wire, the coil, and the number of coils. So if I paste this back in, now it's giving us our results. We learned about solve blocks in that 2-day Prime Essentials class. Okay, what I need to do though is I need to close this out because I only have one license of Mathcad and it's going to launch from Creo. So just closing this out, give it a second. All right, so I've got Mathcad, I meant to say Creo Parametric 4.0 loaded here. And I'm going to go ahead and open up our spring. So here it is. And for those of you guys who are familiar with Mathcad and integrating it with Creo, the old way to do it is still available. If you went to analysis, you could hook it up to Mathcad, either Mathcad 15 or Mathcad Prime. Remember, Mathcad 15 is still supported. So if you're using Mathcad 15, you have the ability to integrate it. Mathcad Prime is here as well. But I want to show you guys the notebook. So if you go to Applications and you have Mathcad and Creo Parametric on the same license file and you're pulling both of them, then you have the ability to either create a worksheet or insert a worksheet. I'm going to insert a worksheet because our worksheet is already created. And let's bring in the spring. Our spring worksheet that I showed you guys a couple minutes ago. Okay, so you can see it's launched Mathcad. I have it over here, minimizing my tray, but if I click this M in the upper right-hand corner, it will take us into our worksheet. Okay, so from the worksheet, what I need to do is I need to designate our input and output parameters. So the equal signs, the evaluation statements, these are things that we're going to be pushing into Creo. So based on this optimization, I want the diameter of the wire to be this, and I want the diameter of the coil to be that, and the number of coils will be this. And then what I'm going to do is, based on this information, it's going to change the spring, and I want the height of the spring to be pulled from Creo and pushed back into Mathcad. And this is a definition statement right here, the colon equals. Okay, so these are going to be our output parameters. So design output. Notice input is grayed out because it's an equal sign. It's an evaluation statement. So I'll say design output, and I can show all of these as a list. Okay, and I know that I want this to be called, I'll call it D wire. Okay, and let's designate D coil as an output. We'll call it D coil, and I know the number of coils that we want is going to be an output. That we'll call N coil. Now, this definition statement is something that we're going to pull in from Creo. So this is going to be an input. That one, the name automatically came in, H spring. Okay, so because I'm tied using the notebook, I don't know if you can see this up here at the top. The save has 3 arrows off of it. What you're going to do is we're going to save and push into Creo Parametric. So I'm going to save and push, and the save and push was completed successfully. So if I come into Creo, if I go take a look at some of our parameters, you'll see that we have some embedded Mathcad parameters now. What I need to do is I need to tie these parameters to our spring, and I can do that using relations. All right, so let's select our spring. I'll go ahead and show everything. Okay, so in our Mathcad worksheet, we are calculating the diameter of the spring, of the coil, right? So in our model, based on how we modeled it, it's only the radius. So let's bring that in. I know that the radius is going to be equal to half, so 0.5 times the coil. So I can right-click coil from down here and insert selected. Insert to relations. Okay. I also know that this is going to be the diameter of the wire. So D6 is equal to the diameter of the wire. I don't have to divide it in half or anything like I did with D1. I also know that the length D0 is equal to the pitch times the number of coils there are. And just based on how we modeled this, I want it to stay symmetric about some data planes that we have in here. Okay, so I also want to bring in that design constraint. So D2 is equal to half of D0, so half of the overall length. Which I could have multiplied by half. Same thing. I just divided by 2. Now to tie the height, the spring, so we can push it back into Mathcad, we need to bring that in too. So the spring is going to be equal to, the height of the spring is going to be D0. If it doesn't let you pick the dimension, come over into the relations. If you activate the relations, then it allows you to pick that dimension. Okay, D0 plus D6. Okay, if you were to look at D0, it's only measuring from the midpoint of the top coil to the midpoint of the bottom coil. So by adding in the diameter of the coil, you're capturing the overall height. Okay, so let's go ahead and verify these relations. They've been successfully verified. So what I should be able to do is regenerate our spring. And here's the overall height. Now, the height's changed. And so there's a notification down here at the bottom saying that our Mathcad worksheet is outdated. So we can come into our Mathcad worksheet and update the table so we see the height of the spring. So you can see that change. Right now it's 0.039. If I say update inputs, you can see how that changed. So as we make changes to our engineering worksheet, let's say the applied load is going to change from 45 newtons to 55 newtons. We're going to save and push this into Creo. We'll come into Creo, regenerate the model. It got a little thicker. I think the height changed a little bit because we're optimizing, we're minimizing the weight. We'll come back into Mathcad to update those inputs. Okay, so we have this tied round trip. We're using the engineering worksheet in Mathcad to optimize the spring using relations. We're tying that all together. The spring is modifying the diameter of the wire, the coil, and the end coil, which in turn is changing the heights, and we're pushing the heights back from Creo into Mathcad to give us this full round trip integration. All right, so that is the integration with Mathcad and Creo Parametric. You do have the ability to integrate with other CAD tools. I believe SolidWorks is another one that you can integrate with. I know you were able to in the past with AutoCAD. I don't know if you can yet with Mathcad Prime. If that's something you're interested in, though, send me an email and I'll do a little homework for you guys. Okay. The last thing I want to mention is that Mathcad 15 is still supported. It'll remain on standard support until at least Mathcad Prime 5.0. So is Mathcad Prime 5.0 going to have everything that Mathcad 15 did? That would be nice if it did, so that way we can get those people off of Mathcad 15 and into Prime. But if not, Mathcad 15 will still stay on support. Okay, so I wanted to mention that. For those of you who are ready to upgrade to Mathcad Prime, you have to use a migrator tool. you need to push it through that migrator engine. But if you only have one license available, what you can do is you can launch the migrator tool from the install directory of Mathcad Prime 4, so it'll only use one license. All right, take a quick screen grab of that if you need it, but I can share this presentation with you as well. All right, so this was our Mathcad Prime demonstration. Thank you guys for joining me today. If you guys are interested in any of the time-limited offers that we introduced at the beginning, please go to TriStar's website and find more information on that. If you have any questions regarding Mathcad, please send me an email. I know a lot. I don't claim to know it all, but I know some people, and I don't mind doing some homework for you guys. So if you need my email address, it is Kathleen.Hernandez@tristar.com if you need to reach out and have any questions for me. Okay, great. I really appreciate you guys joining our call today, and have a great rest of your day. Thank you.